21, 15. Find all possible recipes from given supplies. So for this problem, let me just make a drawing. Yeah. So for this problem, we are going to make some recipes, but the recipes is coming from these ingredients. So for example, for the first ingredients array, we have yeast and flour. So for the yeast and flour, we can make it as bread. Yeah. So this is the ingredients, and this is the recipe. But we need to check if this yeast and flour is inside the supplies. Yes, it is. It is. Yeast and flour is inside the ingredients. It means we can make this kind of bread. So we're gonna output the array with bread. But exactly how can we solve the problem? As we know, there's always a direction. For example, if there are other ingredients, there are other recipes, we can always there's a direction. But inside the ingredients, maybe there's also a bread. If there is a bread just inside the ingredients, maybe we can use the bread to make sandwiches. Yeah. As you can see, this is gonna be a problem like this. From here, we have ingredients, and there is a direction. From these ingredients, we can make some other ingredients, or we can make the recipes. Yeah. So from the ingredients, maybe we can make such kind of recipes. And this recipes, maybe it is a B. Here this B just means bread. Yeah. So for this bread, maybe there is also tomatoes. We can use this tomatoes and with this bread. Yeah. We can also make other stuff. For example, sandwiches. So from this tomatoes here, I will use T. And we can make this S is the sandwiches. As you can see, this is a typical topological sort structure. So this means for this problem, we can use the topological sort to solve the problem. So from the beginning, we have the supplies. We can use the supplies as our ingredients to build the topological tree. Yeah, if the in degree, for example, is 0, it means we've already used all the ingredients. We've already found a recipe. Yeah, so for example, this bread, so this yeast, this is Y, yeast, and this is a flour pointed to this bread. If this is 0, yeah, while we are using the BFS with the topological sort, so the degree will, from the beginning, it is 2, and then it will become 1, and then 0. When it becomes 0, so we are sure this one would be the recipe. Yeah, because this is yeah, while we are building the graph, so those two ingredients are directed to this recipe. Yeah. So from here, the integrate becomes 0, it is not connected, and here the integrate is 1. But for this flour, if this is a tomato, if this tomato also directed to sandwiches. Yeah. So we're gonna continue the BFS. If the integrate becomes 0, so this S1, maybe the sandwich, we're gonna put the sandwich inside the final result. Yeah. Now let's continue to solve the problem. Yeah. So we're gonna build a graph. Yeah. It's gonna be a default dict with list. So this is an adjacency list, and then we're gonna prepare integrate as normal, as usual before. We're gonna use 0 times times n. So this n, let me define this n. So this n is the this n is the length of the recipes. Yeah, because basically we are going to check all those recipes if it is possible to be our final result. Yeah, now we are going to build the adjacency list. So for recipe and ingredient, I will use the singular forms in zip with the recipes and ingredients. Yeah. Now I have this recipe. For example, this is a bread, and I have an array of ingredients, which is yeast and flour. Now I'm gonna check. So for let me just use item. Yeah, so for item in ingredient, I will build the adjacency list. So for the G with this item should append the receipt, because those items will build the receipts. Yeah, it is singular, it will be append the receipt. And the integer for this receipt would plus equal to 1. Yeah. So after this, we will build an integer with the receipts, and we also build an adjacency list with the ingredients ported to the receipt. Now we are going to check which receipt we can put inside our result array. So finally, we're going to return this result. Yeah. Now let me continue the BFS. So yeah, so for the BFS, I will check the ingredients, because I've already have the supplies. Yeah, because I will use the supplies. Because I have the supplies, I'm gonna use a Q should be equal to the Q, and inside I should have the supplies. Yeah. Now I will take it out from the supplies. So I will use like ingredient and pop it as ingredient should equal to q.pop left. Yeah, because I'm gonna use the supplies like this one, I'm gonna check if I can build some receipt. Now I pop it out the ingredient, and the integer, yeah, integer of this ingredient should -1, because I pop it out. Yeah, and I need to check if this integer ingredient equal to 0. Yeah, so this means I've already found one. So if I find one, what I gonna do? I need to append it to the queue. Yeah, so queue needed to. Here I didn't use the adjacency list. I needed to use the adjacency list. Yeah, so this is my ingredient. I pop it out as an ingredient, but I need to check it. So for let me use recipe. Yeah, I need to check if I can put a recipe inside of the result. So for recipe in G with this graph with this ingredient, so the integer for this recipe would -1, and if this integer recipe equal to 0, my Q should yeah, I don't know if this variable is okay, but I will define it as a recipe. So for recipe inside the G ingredient, yeah, because I'm gonna put it inside the result. If first of all the integer will -1, and then I'm gonna check if it is equal to 0. This is the basic structure of a topological sort. Yeah, if it is equal to 0, I put it inside the queue, and my result should append this recipe. Yeah. Now let me just run it. Yeah, this is something wrong. Yeah, let me try to. Yeah, so yeah, let me the integer. I built an integer. This integer is it cannot be an array. I'm gonna use adjacency list. I cannot use array because this is just yeah, some ingredients. There's no index, so I'm gonna use a default dict with int. Yeah. So now my integer can put the recipe and +1, because now it is not an array, it is a dictionary. So I'm from the beginning. So this default dict int, it means from beginning it is always 0. Now yeah, I'm gonna plus 1 for this recipe. So for the recipe, yeah, if there is one item, so the recipe would be 1. If there are 2 items, yeah, it depended on how many items inside the ingredient array. So the int degree would still plus 2. Yeah, so it will be like that. Now from here, I'm gonna check the int degree with the recipe, because if it is equal to 0, I'm gonna put it inside the queue, and the result should append the recipe. Yeah, now let me run it. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time complexity is just for building the adjacency list. It is O E plus V. E is the number of edges, V is the number of vertices. So basically, for this problem, we just use maybe the edges, maybe it is n square. So the time complexity will be like n square if there are too many edges. So that's it. This is for the problem. If you can recognize this is a topological sort problem, then you're gonna solve it easily. You just need to be careful about this int degree. It is a dictionary. It is not an array, because normally for the topological sort problem, they will just give you not just like 0, 1, 2, but for this one, it is just a string. If it is a string, basically we're gonna use the dictionary to check. Thank you for watching. See you next time.